This is a Pele Media podcast.
Welcome back to Jurassic Park Minute. Jurassic Park Minute is the fan podcast that chronicles and overanalyzes the classic 1993 film Jurassic Park minute by minute. I'm Kyle.
I'm Brady.
And today we're here to bring you minute number 26. Aloha, Brady. How are you today?
Doing good. How about you?
I'm doing pretty awesome, man. Pretty happy with the launch of Pele Media, the umbrella kind of for our other podcasts.
That's right. That's right. Already received a couple of emails saying congrats and best of luck.
Cool.
And looking forward to it.
Yeah. We hope it pans out because we'd like to continue doing this for a while, and we kind of needed some sort of unit of protection. So we figured this would be the best way to do it. Kind of, not so much make a podcast network as just kind of a company header, I guess.
Yeah, just like an umbrella that we can do all of these things under, and just call it one thing.
Yeah, absolutely. But hey, speaking of Jurassic Park, you ready to get into minute number 26 today?
Let's do it.
Let's do it. In the previous minute, the group watched an animated presentation on how dinosaur DNA was collected. The minute ended with a shot of a mosquito getting trapped inside of some tree resin. At minute number 26, we see another animated segment. This time it is of two amber miners making a tunnel underground. They make their way through the earth until they come to a particular rock. As they are digging, Mr. DNA says that after a long time the tree sap would harden and become fossilized and would preserve the mosquito inside. At 26:08, we cut to a live-action shot of a block of amber being sanded down and then drilled into by a scientist. The scientist is using a drill to get into the banded abdomen on the backside of a mosquito. Mr. DNA explains that fossilized tree sap is called amber. At 26:19, we see the scientist using a needle to extract the dinosaur blood from the mosquito. Mr. DNA says, bingo, dino DNA. At 26:29, we cut back to a shot of Dr. Grant looking amused at what he is seeing. Mr. DNA goes on to state that a full strand of DNA contains 3 billion genetic codes. We cut back to a shot of Mr. DNA in front of a screen with the letters GATC flying by at a fast speed. Mr. DNA states that if we looked at a screen like this for once a second for 8 hours a day, it would take 2 years to look at an entire strand of DNA. Mr. DNA says that the DNA sequence is so long, it is full of holes. Mr. DNA says that is where Jurassic Park geneticists take over. At 26:52, we cut to a shot of Jurassic Park geneticists working in a lab. Mr. DNA says that thinking machine supercomputers and gene sequencers break down the DNA strand in minutes. At 26:55, we cut to the monitor of a silicon graphics computer where a geneticist is using a virtual reality system to look at a 3D rendered model of a DNA strand. And thus ends minute 26 of Jurassic Park. So this contains one of my favorite shots in all of Jurassic Park, and it does bleed over into the next minute, and that is, of course, of the geneticist at the end of the minute using the, and I'm using air quotes here, virtual reality system to look at the 3D rendered thing. So that's not a virtual reality headset he's wearing. I mean, clearly he's looking at... Okay, so this is such a dumb shot. He's looking at the silicon graphics computer, and he's using his hands to manipulate the DNA, right? So that kind of makes sense. I mean, I guess he could just use the keyboard shortcut of the mouse to move things around, but why not? Sure, yeah. He's using his hands to take a look at that. All the information that they've collected in the computer has made this 3D model of the DNA helix or the strand or whatever he's looking at. I think there's a difference between the two. I don't know them yet. I'm sure we'll get to them in this week's at some point, but... the visor he's wearing in front of his face is a protective visor, so that stuff doesn't fly up in his eyes or whatever. But I think this being like the very early stages of virtual reality, we were kind of not really sure what it was. It was a hot word that people threw around a lot. Now they just say VR with stuff like the Vive or the Oculus Rift or the Project Morpheus or whatever. It's just now coming to its own, which is crazy. But I guess we're supposed to accept that maybe he's looking at some data like Iron Man would on the inside of his visor that we're not privy to.
That's the only thing I can
yeah. Or other than that, they just thought, like, hey, well, this kind of looks cool.
If somebody knows.
Well, I don't know that there really is anything to. I think our guess is as good as any. Yeah, but I think that's what's we're supposed to accept that that's a virtual reality headset when in fact it's just something to protect his eyes.
Okay, well, let me go ahead and.
You scratching out some notes there? Okay, great. And before that, Mr. DNA says, thinking machine supercomputers. And I never understood if he meant that the Jurassic Park geneticists were like thinking machine
supercomputers. I always thought, yeah.
Or did they have giant sequencers that can run through the the Gattaca or whatever the sequence is to create the strand of DNA? Is he talking about an actual literal machine, or these people are so smart they are like machines?
Right.
I think... going back and doing this like breakdown, I think he is talking about a literal machine that we do not see. We should have seen a giant computer with lights like flashing like
You know
like
what?
that.
One of those things. This is one of those things. A perfect example of the fact that you saw this movie at one point, you asked yourself that question, and that's just sort of what you stuck with ever since. You never really thought, oh, well, let me think a little bit deeper into this. Kind of like the guy's visor, the virtual reality visor.
Yeah.
I don't care.
Yeah, it's just fun.
Yeah, yeah, exactly. But okay, so I got a little something.
Yeah, tell me.
All right, the little cartoon where the diggers are going down into the earth and everything. All right, so the second guy is always falling because the other guy's like digging holes down and the other dude's just like falling. And I've always felt sorry for that guy. So as a little kid, I'm like, why's he got it? Can't they like take turns and the other guy fall and get hurt sometimes?
It reminds me a lot of Dig Dug. Did you ever play that game?
No.
Dig Dug, it's this old 80s game where you're digging a hole underground kind of like that. And there's monsters that live in the ground and you're like this digger. And then the monsters will come down and you have to inflate them and pop them. But it also kind of looks like Mr. Driller, who was the son of Dig Dug and has his own set of video games where you're doing the same thing. You're drilling down and it kind of becomes like a Tetris type game. But yeah, it doesn't really make sense the way he's digging. A lot of that hole would fall in. But it's a 2D cartoon. There's an episode of The Simpsons where Bart falls down a well. And everybody comes to the town to try to dig Bart out of the well, and Sting is the guy who digs the most of it, and they have a cross-section cut out like that, and I think Sting is like made like, he's doing like they did, like kind of the, tunnel down that goes back over itself, and where he's not digging, there's like a dinosaur skeleton, or like an alien spaceship that's crashed,
yeah.
So, but anyway, yeah.
That's cool. All right, so we're still in the same sequence where we've got Mr. DNA just giving us this scientific info dump of things that we're going to accept as reality. And I forever have thought that it's, okay, sure, all of this, it sounds plausible. It makes sense. You can clone a dinosaur using DNA extracted from a mosquito that's been preserved, right? And then I was very, very, very disheartened whenever I found out a few years ago that DNA only has a half-life of, I think, 4 million years or something.
Yeah, so I wouldn't even say it's 500,000 years or something. But, actually that can't be right because I was reading a scientific article doing study for this today that they had recreated DNA from a horse that had been frozen 700,000 years ago.
Yeah.
Or they were able to figure it. So I think you're right. It must be over a million years. But it's not... Considering these dinosaurs, I think the youngest of them died out 65 million years ago, that it would just not be possible that that DNA would have completely degraded by that point.
Yeah.
So.
Well, I did a little research, and it sounds like people are even able to put that to rest.
Really?
Yes. So this would be quite an undertaking because the mosquito would have had to have fed from one type of dinosaur in order to have that one type of DNA.
That was always my problem.
Yeah,
but go ahead. Yeah.
Because what if he feeds on, like, I don't know, two different types of dinosaurs in the same day? If you had multiple types of DNA, they're all going to mix together, and you're not going to know what the hell you're going to make or get. So it would have had to have fed on one type of dinosaur. Now, that likelihood is incredibly slim that there's one mosquito out there who fed on one type of dinosaur all the time.
All right.
So there's been kind of a debate in all of this for a few years. Scientists Rob DeSalle and David Lindley have been in disagreement with a lot of people who say that it is possible to clone DNA from a preserved mosquito. And they say that the stomach acid would, more than likely kill any existing DNA before the petrified amber stopped any decay. So that kind of answers what you were saying.
Right, yeah.
But some have been, and some mosquitoes have been found to actually be completely hollow of anything. So, however, in 2004, scientists discovered intact DNA in a fossilized sandfly encased in Cretaceous amber. So,
really? Wow.
Yeah,
okay.
We're getting somewhere.
Yeah.
And it contained the DNA of a prehistoric reptile. So there you go. We're kind of getting somewhere. That was in 2004. In 2013, a fossilized mosquito was found in Montana that contained almost completely intact DNA, and that was proof that DNA can possibly, that's a key word, possibly survive in an insect's gut. So in some cases, the need for the mosquito isn't completely necessary. There's actually been dinosaur tissue found in amber. So let's say there's dinosaurs fighting or something like that. One's thrown up against a tree. His blood is suddenly caught in the sap. Right. Something like that. So tissue from the Mesozoic period was found in 2002 in Lebanese amber. So again, we're kind of getting somewhere. In 2005, dinosaur tissue fragments were discovered in France from the Cretaceous period. So there was a paleontologist named Dr. Derek Briggs, and he stated in his article, get ready for this title, "A Mosquito's Last Supper Reminds Us Not to Underestimate the Fossil Record." That's the name of the whole thing. And there's a quote in it where he says, "The well-fed mosquito forces us to revise our ideas on the limits of fossilization. Investigating the conditions of preservation indicate what new information might result from future excavation and collecting and novel applications. emphasize how future technological advances will yield data that we cannot yet imagine. So this kind of echoes the words of Ian Malcolm a little bit. For us to think that we presently have all the answers is kind of big-headed.
Right.
And we're not going to know. And even someday, whenever we do have even further evidence that this could possibly be possible, there's still going to be so much information for us to find out from that point on.
Right.
So
we know very little of it.
It's possibly possible, and that is exciting to someone who would love to see this happen.
I think it sounds like it'd be more easy for them just to make DNA up on their own. Be like, figure out like what makes a hand or a foot or something like that, and then map it out to be like a reptile's foot with a claw, and then just build it up from that point. But it's kind of sort of like the Indominus Rex in Jurassic World, which is just a complete creation of from the ground up, that kind of thing.
I remember seeing a documentary a few years ago, maybe like Discovery Channel or something, where there was a guy who was trying to mix like bird DNA with reptile DNA. He was basically going to do what you're saying, is like try and create something from the ground up instead of trying to clone prehistoric tissue or DNA. So
cool.
I don't know, man, but it's like we've gone back to before. Like, what then? What do you do then? Once you say, "Oh, it's possible. Check it out. I proved it." What then?
Yeah.
So
well, I guess you make it. Yeah.
I guess you make it.
Stick it in an ostrich head
and start a theme park around it.
So one question I kind of or one thing I didn't understand was the gene sequence gaps. The gaps, I never really understood like what that was about. I figured that, well, if you get the DNA, then why isn't it all there? But I guess part of it is that there would be some issues with it, right?
I guess decay over time. Well, go ahead.
Yeah, so I looked up on the Jurassic Park Wiki kind of an answer for this, and this is from the Jurassic Park Wiki. In the fossilization process, molecules are altered. DNA in amber or bones cannot survive completely without gaps for tens or hundreds of millions of years. The novel attempts to address this problem by mentioning that Hammond and InGen have purchased virtually the world's entire stock of amber in the quest for the maximum number of possible samples of blood from ancient mosquitoes. Even after reassembling, fragments of code would still contain gaps. To successfully clone a dinosaur, DNA has to be correct. It has to contain every chromosome, and that should contain no sequence gaps. So kind of like what we're talking about there, things like the mosquito blood mixing with it, that they would have to fill in these gaps. They're probably random, just like reorganization of the DNA sequence until they get it to click, right? So that would explain, if InGen was able to buy up all the amber, they would have to have all the blood from all the mosquitoes, and then all of that cataloged in a computer, and then like a computer that's able to reassemble all those codes to recreate dinosaurs. So we're talking about a lot of computing power.
And to detect what's Stegosaurus, what's Velociraptor.
Yeah. That's the thing, is figure out like, okay, well, is this a dinosaur? Yes. Okay, are all these codes of the chromosomes complete? Yes. Okay, well, this is one. We catalog this here. Here's how to recreate this from protein strands. And it's very interesting, but it's just the task of tackling it is so gargantuan that it would take, a long time to happen. But like you said, we're getting probably closer every day. We don't even know it. But I'd really like to see some Paleolithic type stuff cloned first. Woolly mammoth, saber-toothed tiger. I think that's probably a little bit more closer to happening.
Yeah, a little bit more tangible at this moment. But exciting stuff, man.
Very exciting. And a lot of this is over my head, but it's really cool to kind of read up and think about on.
I also want to say that all of the information I got about Dr. Briggs came from the Jurassic Park Wiki.
Yeah, and and mine as well. So. Yeah. Go visit that. It's I'm sure that everybody who listens to the podcast probably knows about it. So.
Yeah.
All right, well, you ready to get out of here?
That's all I've got.
Awesome. That's all I've got as well. So, folks, we will be back tomorrow for minute number 27 of Jurassic Park. I'm Kyle.
I'm Brady.
And until next time, hold on to your butts.
Jurassic Park Minute is a fan-supported podcast. If you like the podcast, then leave us a review on iTunes. You can contact us at JurassicParkMinute@gmail.com and visit us online at JurassicParkMinute.com, Facebook.com/Jurassic Park Minute, and Twitter.com/Jurassic Minute. You've been listening to a Pele Media podcast. For premium content and exclusive podcasts, visit us at patreon.com/Pele Media. Check us out on Facebook at facebook.com/Pele Media and follow us on Twitter at twitter.com/Pele Media.